Hello, the topic today is how do I calculate my H-index. Again, to review, the H-index is the nth paper with n citations, sorted by highest number of citation first and going down. And this graph gives a great representation of what that means. Your first paper has the most citation, second has a little bit less and less and less, and this may be like 30, 20, 15, 15, whatever, 8, and then at a certain point, this would be the fifth paper, the sixth paper maybe has only 5 citations, and so your H-index would be something like 6. We'll see another example soon, and it'll be more graphical as I explain it. But how do you calculate your H-index in astronomy? So far, what we know is from Google Scholar. You just go to you're logged in with your Gmail account, and then you can go to My Citations, and it gives you all kinds of statistics on your citations. If you're a member of Google Scholar, then you actually have an affiliation, and you have a email address, verified email address, and so on. And right here, you see the H-index for all or a recent H-index, which tells you, oh, she's been cited recently. But actually, this is not my H-index because it misses quite a few papers. And also, there is a problem that some people will not get recognized. So while I'll search for a famous astronomer, and that is actually the Simon White I was looking for, and he has an actual high H-index, there are some famous astronomers that I can search for that are not members of Google. This is not the Martin Rees I am looking for, and so I cannot get the H-index for that famous astronomer. So you usually go to, this is the old school way of doing it, you go to the NASA ADS system. This is the old school ADS system we all know and love, and so you look for your name, and remember to click on both, and I think this is not important, but click on all databases so it actually searches across certain fields, because other fields might cite you too. For example, if you have an SPIE conference paper, although that's not refereed, but if you have something that is in physical review letters or something like that, that might cite your work, it is important that it gets cross-referenced in this physics too. And remember, normally the H-index gets calculated for only refereed articles, and so remember to click on the all refereed articles. And so it's searching for my refereed articles, and it says, okay, you got 19 abstracts, so 19 refereed papers. And so now you want to sort that by citations. So the highest citation gets posted first, and so you have my highest is the first one, then the second highest has 37, the third has 29, and so you move down, and the sixth has 14, 7, 13, 8, 12. You see these two lines are starting to come closer. 9 has 11, and here's actually the number where 10 meets 10, and here it actually has crossed the line. So my citation and my H-index is 10. We can go and do this same exercise for, of course, the same 2 famous astronomers I did before. So you go for Simon White, and here actually he has a few more papers than 19 refereed papers, so I'll just go and put 10,000 in there. And only refereed articles, and so I'll send off the query. And as I said, he has a little bit more than 19 refereed articles, and so it's 13, 10. And here it was actually important that I click on the physics, because he has quite a few physics papers. Again, we sort by citations, and it actually takes a little bit of a while. Here you see the browser working, but we can actually start to move down. Here's the famous Navarro-Franken-White dark matter profile, and so we go down, down, down. 19 goes 896 citations. We go to 50, that has still 429 citations. 75 has 277 citations. Number 100 has 221 citations, so we're still far off. So he's a very prolific writer. He's still going up. But now we're starting to meet again. And it's not very scientific, but we see that 152 meets 152, while 153 already crossed the line. So his H-index is 152. This is quite prolific, and we can go and do the other example we had. Rees, Martin, and we have a lot of results, and we have all refereed articles, and we have all sorts of articles, so we send off the query. And again, you have close to 500 papers, and we sort them by citations. And again, there's of course very famous papers we all know, and we go down, 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 down. Here, the citation index is still very, very prolific, but not as high as Simon White's citation index. Here you see the two actually meeting. And here you see them meet. 107 meets 107. So Sir Martin Rees' H-index is 107, while 108 has already passed. So this is the old school of doing this. But now there's a new ADS system, the ADS 2.0 system. This is actually the continuation of the ADS Labs system, and this is the new address. Now I'm gonna warn you, the ADS system is not 100% complete yet. There's still some bugs, but you can already use it and start to play with it. So we're actually querying the author. First we go again with mine. So we go to query for my papers, and you here see I have 1 physics and 50 astronomy. This is actually correlated. There's only 50 papers that I have. And so you can actually now analyze via these metrics for all 50 papers. And this is actually quite nice. What it gives you all sorts of statistics. People really starting to read the papers I'm an author or co-author with. You see that I have not published any refereed papers in 2014. And here you see how the citations are picking up per year. And here you see there's different metrics that are increasing as the years go by. And here's my H-index for refereed articles. It is 10. And we can do the same exercise with the two other names we had a set. We analyze it via the metrics. I'm not really sure if it was 1900 on the other metric too, but I think that we had said that the H-index was 152, and here you see 152 as the H-index. You see, normally non-refereed papers don't get cited as much. And here you see how the citations really start to pick up, even though the publications had some dips on some years, but now they're really starting to pick up. And then we do the same for the other famous person. I think we had said that he had a H-index of 107. So we do this for all these papers. Here there's way more papers. I'm not really sure why there's so much papers for astronomy, but the H-index, as we had calculated before, is 107. And so now you know how to calculate your H-index. You either go through the normal measure, the old school results of actually sorting it out and seeing it happen, seeing this index, this graph happen manually, or you can make the ADS 2.0 make all the work for you. Okay, have fun trying it out for yourself. Bye.